Okay, lesson 84 has two parts to it. So let's do this one first. This is on multiplying square roots or numbers under radicals. And we've done this before, but just to review real quick, if I have the square root of m times the square root of n, you could equal it times the square root of m times n. You can combine them underneath the radical. And likewise, if they were already together under the radical, you could separate them and say the square root of m times the square root of n and put them under different radicals. Doesn't change their value. Let's use it with real numbers. If I'm multiplying 4 times the square root of 3, they're right next to each other, so that means multiplied, times 6 times the square root of 6, then that's the same thing as saying 4 times 6, I'm sorry, I'm going to make that a 3. 4 times 3 and 3 square root of 3 times the square root of 6. I just rearranged it like we did in that other lesson. So that would be 12 times the square root of 18. Then I look at this square root of 18 and I know that there's a perfect square within that as a factor, and that would be 9. So 9 times 2 is 18. Square root of 9 is 3. So I could bring that 3 out. That leaves the 2 behind. So I have 12 still, but now I have 12 times 3 because I brought this out, and I still have the square root of 2 there. Then I multiply these together and I get 36 times the square root of 2. So that's how you do that, and we're going to do one more. With this one's with the distributive property as well. You know how they combine things. So if I have the 4 times the square root of 2 times this equation, 3 times the square root of 2 plus 5. So I distribute that out. So 4 times the square root of 2 times 3 times the square root of 2 plus 4 times the square root of 2 times 5. So I'm going to do these right here. That would be 4 times 3 is 12. 2 times square root of 2 times square root of 2 is 4. We know that's a perfect square, so that would make that 12 times 2, which is 24. This over here, 5 times the square root of 4 times the square root of 2, that would be 5 times 4 is 20 times the square root of 2. Nothing you can do with that, so I just brought that down all the way, and this would be your answer. So you have a couple of problems with that. That's very simple. I think you can handle that. Then we're back to functions again, and I'm going to include another video I want you to watch on YouTube that will help you sink this in. But you really also need to read their description. They're very good at describing it, and so rather than me just stand here and read it to you, I want you to read it out loud. Go in a room by yourself and read it out loud. But let me go over a couple of things. Remember, domain is the input, range is the output. So domain is whatever number would work in this equation. It could be a mighty group. But once it's in the equation, what is your output? That would be the range. And so here we have what we call a function machine. And the function machine has this in the middle. That's the equation. And here's my domain. My domain is 2, 4, and 7. So if I put that in and I substitute in 2 for x right here, that would be 2, that'd be 2 squared, that would be 4, plus 5 would be 9. So I could put in a 2, comes out a 9, that's my range. Put in a 4, comes out 21. Put in a 7, comes out 54. So this is the function machine. Remember, domain is your x, y is your range. And so sometimes you'll have coordinates and you'll have a set of coordinates. And so the x's will all be the domain, the y's will all be the range. And they will have you decide if it is a function or not. Now this is where I want you to, this is new, and I want you to watch that video and read what it says. Now let me talk about that for just a minute. So a function can be described as, well, let me read it this way. I had it here just a second ago. So the rule for a function may be stated if you have a list of ordered pairs. So ordered pairs, you know, like x, y, x, y, x, y, x, y with numbers in them. Stated by a list of ordered pairs such that every first member is paired with exactly one second member. Thus, the following set, I'm on page 347. And so if I have 4 with 3, I have 5 with 7, I have 9 with 3. You can look in your book right here with me. And so each let me read it again. So that every first member is paired with exactly one second member. Okay? Thus, the following set of ordered pairs defines, oh, this is a relation, sorry, does not describe a function. Sorry. So a relation can have one or more. So, and this diagram right here kind of describes it. I'm sorry, I said that incorrectly just now. So I have a relation here. So it could be with one or more. This could go in as a 4, it could come out a 3 or a 5, and this 2 could come out a 6. But with a function, it has just one. See how this can go out 2? It could have the same one. These could come out and have the same answer, but like if it was x times 0 plus 3, no matter what x is, it's going to be plus 3. So we know when we multiply anything times 0, so if it was 4 times 0, that'd be 0 plus 3. You're going to get a 3. 2 times 0 is 0 plus 3. So you're going to get a 3 no matter what. That's still a function. But if you put in one number, you can't come out with two numbers and it be a function. It's called a relation. And so that's what they're trying to distinguish here, is the difference between a function and a relation. And that's what that video is going to be about. But then there's some rules down here I want you to really read. And I'm going to let you read those. It's not hard. And then they give some examples of what functions and relations, which ones they are. Is it a function? No. Is it? Yes. Is it a relation? Yes. Is it a relation? No. And so you're just learning how a relation can come out with two different numbers. A function cannot. You can only have one number come out of it. And so that is the point of this lesson right here. Don't get bogged down on the machine part. That's easy. We're just talking about the difference between a function and a relation. And so that is that. Look up the video.